Hey everybody, this is a video that we did several years ago. Y'all can tell, don't comment on my hairstyle, okay? But the bottom line is this: it's a great video. It's about how we prep a gear case and the things we found as far as they were design flaws and corrected them. And we since had really good success. Basically, a racing gear case is a surface piercing gear case, and we're going to be using these on our new prototype outboard motor. Surface piercing or surface piercing prop is absolutely the way to go for any boat that's traveling at any speed more than about 20 miles an hour. So this is just for the tech heads. If you want to know how to prep a daggone lower unit, all right, this is what it's like. But we're going to be doing a bunch more videos on our outboard motor. It's patented all over the world now. It's pretty cool. But anyway, thanks so much. I hope you enjoy the video. Oil change, Jay, for doing lower units, and we're going to talk about Yamato gear cases just a little bit. And what I found over the years, we had a real bad problem underneath our RC5s when I ran a heavy load of fuel, which was when I ran nitro and some other good stuff. We could briefly boost to obscenely high horsepower ratio. And what happened then is I would twist drive shafts like a barber pole, and I would grenade the lower unit. This is one of the things that I did to make it stop, and I eliminated, literally stopped, lower unit failure. This is a standard Yamato lower unit. It carries oil to that level right there, and we're going to talk about that in just a minute. This is what we call a super unit. Now the super units, we're changing the oil in some of them, and you can tell a super unit is going to have a couple of things. First off, it's going to have this. You're going to see this thing here in the back. That's actually for a remote oil reservoir. You're going to see a high oil fill right here, and that's a dead giveaway. And I don't give away what gear ratio I'm running, so I have a code right there, so I eliminate the gear ratio. Also, we have to run them on a shouldered bolt so the unit stays perfectly aligned. So you'll see our lower units have 10mm holes through them. But we can simply put a shouldered stud through there and put it back. But we ran, like I say, a shouldered Allen bolt through there. But anyway, let's go over here and talk about what goes into a super unit. Now, I got an O'Koenig 1-to-1 unit right here. And basically, I want to show something. To get oil to a bearing, you have to have a way to get oil in and then a way to get oil out to make it pass through. All right. Here, if we notice, see, there's no passages in this unit, and that's the way that these units come. Also, that top bearing is shrouded, very heavily shrouded. The bearing that's up here is very heavily shrouded from oil. There's no real way for the oil to pump up to it, or not enough, because what we were having was a problem. We would blow gear cases, and when we blew gear cases, we would have them welded. I mean, we would literally blow the whole sides out of gear cases. This is one that's been welded up and remachined, hence all the flaws in it. Now, what we had trouble was we thought, like everybody else, that we were blowing gears, when in reality we had a situation that was causing the gears to blow. And here is the #1 culprit of why we had the gears blowing. And basically, let me put my hand on it because I saved one of them. And where is that? Put the at? Oh yeah, that's a bearing that goes right there, and that takes the actual upward thrust of these helical gears. Now these are Koenig gears, but I'll tell you what, I'll show my Yamato gears. The Koenig gears are nice and beefy, they're just awful big, but what happens is when the pinion tries to turn the prop shaft, what they want to do is push themselves out of engagement. That is the nature of a helical cut gear. They actually try to push themselves apart. Now, if that gear is fully engaged, it puts all of its load at the root of the gear, which is very, very wide. Now, if it comes out of engagement, or if its backlash changes, what happens is it'll break one tooth off, and as soon as it breaks one tooth off, then that jams it, and then the failure is cataclysmic. In other words, the failure is profound and goes right on. Anyway, I could not find anywhere in industry where one of these bearings was used as a thrust bearing for a helical cut gear. This is actually a run-out bearing. This is out of a Yamato unit, but this is actually takes the daggone run-out of an alternator. It is not rated for anything near this kind of load. Now I talked to every bearing person in the world, it seemed like, but I got really good information from Timken and Torrington. Now what they told me first off is these are a standard set of bearings that come out of a Yamato unit.
Now basically, if you look, there's no outside jacket. The oil has to make it all the way through that bearing, you see what I mean, to actually oil the bearing. Now what happens is this. Basically, the theory is we'd like to get oil down the daggone shaft and actually spin it centrifugally through the outside. So what we did is we changed and we found bearings like this. If you notice, it has an oil race around the outside, and then we drill a return for that race. So when that bearing sits in that thing, what happens is when we take oil down it, it centrifugally forces the oil through the daggone needles and back down that return. And what that gives us, or it may, you know, actually it could run the other way, I don't care, is what the engineer said, that what you have to have is a way for the oil to get in and a way for the oil to get out, taking into effect the forces that are available. And we're turning a shaft 13,000 RPM. What we have is centrifugal force more than anything. So if I got oil walking up the shaft, I have to give it a place to go. All right. Now, this next thing, so all of the bearings, all these bearings were replaced, and we put this type of bearing in. Now, some folks already use that, but that's great. If you notice, there's a return rifle drilled right here in the back. There's a return rifle drilled every single place that those bearings go. There's also a return rifle drilled right here before this tower bearing, okay? Because that's the one bearing that I could not get a daggone outside groove on. So we wind up having to use a Yamato style bearing that doesn't have a return rifle on it. That's got that package on it right there. Let's see, if I have a failed set of gears here somewhere, Now, that bearing right here, this tower, what we call a tower shaft needle, was kind of hard to find. So basically, we had to get these. These are bearings directly from Yamato, and they actually, we made it to where the oil can get to the top and run through them. So here's how we did that. We raised the level of oil in the lower unit. We needed very desperately to get oil to this top bearing and make sure that we could get oil all the way up there. And I did this as part of a dry sump thing, and we'll talk about that in a minute. But basically, this is a brand new Yamato case that's been remachined to accept what we call, turn it into what's called a super unit. Now the super unit, basically what it has, let's see, this one has not been machined as a super unit. What happens is we see this shoulder where the original bearing goes, that smallness right there, that small diameter, tends to shroud the balls from oil anyway. So it has a very hard time of actually getting oil up there to it. So that outside rifle right there that's drilled in it, this is one of our early units. Now this is one that's been machined for a Timken bearing. Now we're going to talk about that in a minute. But if you notice that oil rifle right here, there's an oil rifle, and I'll send a set of drawings. That oil rifle right there, make sure that daggone top bearing gets oil to it. We actually pump oil all the way up there, and I will talk about that in a minute. For a while, I thought that I had to make an impeller, and I did make an impeller. This little unit, this spacer unit right here, this is a moly disulfide coated set of brand new gears. But this spacer unit right here, we actually remachined it and made an impeller out of it. We actually machined an oil pump into it and created a true dry sump lower unit where we circulated oil through the lower unit and carried it to an outside reservoir. That proved to be a little bit of overkill. We didn't really need that. But we went to that extreme at one time. And this is a blank that we actually machined the pumper out of. But basically, oh yeah, and because we literally would push the shaft through the unit, these holes right here are so that spacer can be tigged to that shaft, so this gear cannot move, and the shaft, because that proved to be a very serious problem. But anyway, by tigging this spacer to the shaft, that thrust washer right there that sits right here held the shaft absolutely solid, so our prop shaft quit moving. A lot of guys still, that's just a cyrogenic fit. It's like a class 3 or 4 fit, and they press that in there. And for the first time that you change that gear on a prop shaft, and if you warm that gear up and cool that shaft, you'll get a decent fit. But if you ever press that son of a gun together at room temperature and don't differentiate the temperature, what'll happen is you'll lose some of that daggone fit. And if you've got a really good C or a D, you'll actually push that prop shaft right through that daggone gear and keep it right on going. And so henceforth, and this one is welded too, it's just machined down. But the bottom line is we weld that spacer to that shaft, okay? That becomes, and it also locates our gear, so when we have to, if we ever change the gear, which has happened, we actually just go right back to the spacer and that resets it. But the biggest thing that we were killing, here's the killer. The number one thing that was killing these lower units was that while we wanted to hold that perfect 20,000 backlash under terrific load, this unit right here was falling out. It was failing this bearing. This bearing was holding the thrust against it, and it simply would not do it. That bearing would fail. The gears would come out of phase. The backlash would be too great. Your load transfer would come away from the root of the daggone gear, and from the root of the tooth of the gear, and you'd wind up breaking the gear off, and after that, failure was catastrophic and instant. So, here's the deal. This is why we went to such extremes with the daggone oil thing, because my notes from talking to the Timken engineers, and I talked around, because I wanted to put a Timken tapered roller bearing in it. Now, would a Timken tapered roller bearing run at that RPM? And they'll run as high as 5,000 feet per minute. Maximum recommended rolling element speed and 80 well in submersion. Every one of the engineers wanted that bearing to be literally almost in submersion. At what, 4,000 or 5,000 RPM feet per minute on a bearing this size will give you about 14,000 RPM, okay? And the source, this is Bob Wolf from Timken Bearings. So here's the deal, and I'm going to give all the part numbers and everything to it, but basically what we've done is we match a Timken rolling element bearing we remachine the house, a Timken rolling element bearing. I'm going to reach over here for a race. Let's see, a race in there. Get my and this is the matching race, and you actually ordered them separate, but basically this is a Timken tapered roller. Now what I do is I put that bearing in the top of that unit. Here's what we have to do. It fits wonderfully because this is a unit that's been machined to accept that bearing package. Now actually this is actually an oversized race that goes in the bottom. That's another experiment. Let me show you the ground down races for that particular application. Okay guys, so now that I got the right bearing, what it is, I built a couple of different assemblies. Basically that right there replaces that bearing. That is a Timken tapered roller bearing. It's good to about 14,000 RPM. Even in an oil spray, in an oil submersion, it'll go higher than that, about 15,000. In the notes here, call that number. Let's see, 4,600 feet per minute, rolling element speed with a suggested bearing, and that's 15,000 RPM is what she'll stand. Okay, at 4,000 feet per minute, a rolling element suggested bearing, that's about 13,000 RPM. Well, I have never got a rolling element problem. Now I've never, once I changed to that bearing, that ended everything. All of the problems stopped. What that will do is that will absolutely locate that daggone, that pinion bearing. Absolutely locate that pinion shaft. So your tower shaft stays perfectly in phase. Now, when I shim out this package, I'm sure everybody that ever is worth their salt, you know, building one of these, when I shim out this package, we shim all of the play out, all right, and we actually lock this shaft in space. It should have no play back and forth whatsoever. And now this is real important. I use a Torrington bearing, and I'm sure anybody that's worth their beans, you know what I mean, will put, if you feel these, you can actually feel the etching on that number. I hate that. There's a fag part number. Always put the smooth side to your gear, of course. Never put the letters to the daggone Torrington bearing. I'm sure I'm probably telling people I already know. I don't even like those being in there. There is a FAG, F-A-G part number that comes with the German Koenig unit. If you notice, I don't have any thrust washers for this unit. The reason for it is I pirated them all building my lower units. They have just an acid etching. Now I've got the FAG part number, and I'll give that, of course, when I send the stuff over. But the deal is this. Ideally, we're gonna put oil rifles, and I'm gonna send a good drawing, and I'll give Tony this so he can actually get it up on this film, of the oil rifles We remachined this top unit with an oil rifle up and a big oil return. If you'll notice right here, this is very critical. Notice how large that oil return is. Basically, we send, when the gears turn here, this right here will actually capture the sling of the daggone gears, and it'll send just a geyser of oil up to the top here, which will actually wet the dickens out of this rolling element bearing and then fall back down. It has to come back down through your tower shaft needle bearing. This fella right here, it actually has to fall back through that tower shaft needle bearing, and what we wind up with is just a superb oiling in the lower units, and all of that bluing of the shafts and stuff like that you get, all of that disappears. The reason this shaft shows a little bit of heat treating track is because that's exactly what it is, and that's another story. When we do all this, what will happen is the one place the Achilles heel of that lower unit will be revealed, and where the Achilles heel is going to be revealed is right there. Is that shear pin drive. That's the thinnest part. That's where that's the weakest link. Because once we did this, once we put a set of oil rifles in here to where we had through oil and bearings, and once we put an oiling dag on and we machine this right here, this catch area is a little bit bigger and smooth and polished, so we actually send oil up that rifle. And we did this early on, but even before, as I was chasing the lower unit failures, I was getting bluing on my shafts, and I chased the oil problem out first, and we got them to oil good first, and they still blew up. And it was, at the end of the day, it turned out the changing of that bearing, that one, okay, ended it. So what happened was after I went to this bearing, no amount of nitro, no heavy boat, no bigger wheel, nothing could fail one of these lower units. And this drops in and uses the exact same place for the daggone key. All right, you have to machine this shoulder down about 120 thousandths, about 1/8 of an inch. There's plenty of meat there. It has no effect on the strength of the lower unit. The high fill hole right here, I actually put that as a vent hole. If you notice, it goes right to that land right there. But what I do is when I lube those lower units, I actually will, and I got to do this, as everybody else knows, when you fill the lower units, you fill it here till it comes out that hole. Well, all you do is when you pump it to lube 2, all right, I fill it to that hole, put the screw in that hole, and I give it 2 more squirts. And what that does is that gives me, while I got this screw out, that puts me a level of oil about that big. All right, about that, and that still gives me a sufficient air pocket if I use a very good oil. Now, I use, walk over here with me, Tony. Ron's machine in there. I use Blinzall gear lube because it does not, and I don't really care what gear lube you use as long as it doesn't foam too bad. All right, now here's something that I did for kilo work or when I was running absolute ultimate horsepower, okay? I would fill the lower unit completely up with oil, and then we used a pressure transducer. That's what that hole is right there. Now you'll see in all my other units that's just blocked off. It just has a plug in it. Basically, that unit went right there. And what that did, that let me fill the unit all the way up with oil, and this right here is a diaphragm with a spring on it. And basically, as the lower unit pressurized, it would just simply push that diaphragm up. And if I wanted to add oil to the unit or bleed air from it, I just did it through that Zerk fit. But the bottom line is, if I'm running kilo, or if I'm running endurance, or if I'm running an ultimate thing, I would fill the lower unit completely up with oil and use a reverse bladder, just a remote reservoir to allow for expansion. But basically, the oil rifles, remachining to daggone, let oil get to that tower shaft needle, the Timken tapered roller bearing at the top, that simply ended lower unit failure. And I want you to know I failed in 89 and 90, 91, we started getting real strong. I started failing a lot of lower units. Once I got it to stop, I mean, that was it. We didn't have that problem anymore. Now these part numbers, I will send them to Jim, the outside bearing and race. I will share this information with you. I share this information that's free. It cost me a lot of money to daggone find it. You can use it if you see fit. But the deal is, I blew up a lot of different things and I tore up a lot of stuff. But when I did the things that what I just talked about, Gentlemen, I quit blowing up lower units. That's it. I never blew another gear case, and I made a lot of horsepower. All right. If I could only have won some races, it'd been all right. But the deal is, I will give the part numbers. Send along the part numbers. You can take this technology all the way. In closing, probably the best all-around lower units are the ones I run right here. We run these and put 240 horsepower through them. Basically, that's just a standard super unit. Okay, you can tell it's got a high oiler, you know what I mean, and it's got the plug for the remote reservoir if you need it, and that's a standard super unit. These units, once I built them, I've got 5 of them online now. Like I say, that's it. You build them one time, and that's the end of the story. But anyway, I'm going to include the daggone part numbers. I have the machine drawings for the exact modifications to the Yamato gear case. And Jim, I hope it does you some good. Thank you.